Yuzo, are we there?
Yeah, let me also manually set it to be live. So yeah, we are live.
All right, welcome everyone. So today we'll discuss the open source and all questions about it. So today it's probably fair to say that most students, when they start their career, when they even start their education, are we there?
Yeah, let me also manually set it to be live. So yeah, we are live. Is that?
Okay, all right, welcome everyone. So today we'll discuss the open source and all questions about it. My problem. Okay.
Okay.
Yeah, so welcome everyone again. So we are a small and independent group of researchers organizing talks, podcasts, and panels, primarily targeting the students in computer systems. If you like this discussion, please follow us on Twitter and LinkedIn. My name is Dmitry. I'm an assistant professor at NTU Singapore, and my co-moderator is Tzi Xuan, PhD candidate at UC San Diego. So we'll talk about open source and how to make it useful for our day-to-day research goals. So to figure it out, we invited 3 renowned academics leading famous and what's important, impactful open source projects, with the first panelist being Sarita Adve, from a professor at Illinois Urbana-Champaign, who is leading a project Elixir, which enables research in extended reality. It's a new emerging hot field. The second panelist is Jason Lowpower, who is a professor at UC Davis and the leader of probably the most widely used architectural simulator called Gem5. And the final panelist is Grigory Forsting, who you may know as the pioneer of artifact evaluation initiative at systems conferences, and who was also previously vice president at of MLOps at OctoML. So welcome everyone, and let's kick off our discussion.
Yeah, welcome everyone for joining, and thank you for the time for taking this time to share your valuable experience in open sourcing. So we'll start with some very interesting questions as a first time open source experience or something like that. So the question will be how to open source a research project if you don't have any prior experience. So the first thing we would like to know is when should we think about a project it is ready to be released? So as students, I open source a few projects after a paper publication. So something like, can one think about open sourcing their source code right after a research project or anytime later when they are ready? Or when should be a really good time for a student to open source their projects? So that would be our first thing we would like to know. So any opinion would be very helpful. Yeah.
Who wants to go? Okay, I'll take it.
You can start.
There's nobody else will go first. So we open sourced Elixir before we had a paper on Elixir. In fact, our paper kept getting rejected, and another group published using our open source software before our paper was published. So I have an interesting story to tell here. I think people should open source their work as they're doing their work, because it's really important to build on each other's work. And these days, for the most part, especially for systems, the work is so software heavy that, or even hardware for that matter, that it's and the papers, it's often difficult to figure out what did the authors really do when they publish a paper. And so I think it's really important to have the code for the paper available for others to build on. And in case of Elixir, the whole goal was to provide infrastructure for the community to make progress. I mean, that was our intention from the get-go. And so there was no question for us that we wanted to release our code, even though there was a lot of trepidation in the group that we're releasing this without a paper. What are we doing here? But I still remain convinced that was the right thing to do.
So I guess I'll add on to that a little bit. In some sense, I think it kind of comes down to what do you mean by open source? Do you mean just throwing it up on GitHub? In which case, yeah, you should do it immediately.
Yeah.
I mean, you should be careful about doing that. That there's things that come with that when you do put it on GitHub. You do need to think about things like licensing and stuff as you're doing that. But putting it up, making it available in terms of open is something you should do very quickly. If you're thinking more about trying to build a community around it, especially like what Sarita was talking about with Elixir, then maybe you should be a little bit more careful about how you go about open sourcing it. Think about building some community structure in it before you just throw it up on GitHub to make sure that the community is built the way that you envision a community.
And from my side, I think I agree with both of you that when we start working on new projects right now, we start a GitHub project. We're not starting like writing a paper and so on. We start a GitHub project and continue working with the community from the start. But the question probably is for researchers, why they should ask themselves a question also, why do they want to open source their code? What is their purpose? Because it's again, exactly, you can just throw your code on GitHub, but no one will ever look at it. And then if someone is using it, you can have issues. You can decide for yourself what they want from that. Just reproducibility, building a project, getting community. There are many things to opening sourcing the project.
All right, that's cool. So I guess as students, what if we can do like as a single person open source project, we can do it as fast as possible. But if we want to make it a community, we should really think about it before doing it. But in general,
we can. I mean,
it
can happen. If I may just add to that, right? So they're not mutually exclusive, right? So you can. So what we did with Elixir was we put it out, right? And oh, by the way, I totally agree with Jason that just throwing out a bunch of code without worrying about its quality is not very useful, right? I sort of took that for granted that when you, I mean, for us, we're not always successful at this, but certainly for Elixir, high software quality was always important through the whole, I mean, from the day we started working on the project, all the students were committed to that the code quality needed to be really something that we'd be proud of. And just the engineering of the system was from the get-go, it was designed to be usable by others so that we could build a community around this. I mean, that was always the sort of the goal. And so we put it out there as soon as we could, but then we developed sort of the infrastructure, the sort of community infrastructure around it over time. And that took a while, right? And so it doesn't, these are not mutually exclusive things.
And that's very useful. And also it doesn't have to happen after a research paper got accepted. So probably we can even think about before getting a paper accepted. So that's cool. And moving on to another question, it will be something I'm personally also interested in. That would be is there any difference between the prototypes and to be open sourced projects? Because we know research projects initially start as a prototype. It could be messy, it could be like code quality, it could be like really a mess. That would be a prototype stage or some other kind of prototype stage. But once we think about open sourcing, what's the difference between a prototype and a ready to be open sourced project?
I mean, I think anything's ready to be open sourced. I don't draw any distinction between the two. And it kind of sounds like both Sarita and Grigori were saying something similar. It's like at the beginning of the project, you create a GitHub and start pushing there. So even in the prototype phase versus in the more end goal phase, it's open the whole time. I think that one thing to keep in mind as students is that if you write research quality code that isn't really usable, then it will never not be research quality code. You need to be thinking from the beginning to write high quality code that, no code's perfect. It doesn't have to be perfect code before you put it out, but I would encourage people to not think about writing research quality code and then someday improving it, because someday will never come.
That is true. Oh yeah, sorry, just one thing. So that is correct. For me, I think once again it gets back to why do you want to open source your code. For me, it's I have a parallel. I can draw a parallel with open source code with a startup. So you can spend 2 years writing super good code and no one will ever use it. But the best thing is to continue like pushing prototypes, test it with the community, improve it, and continue improving it based on the feedback. And the sooner you do it, the better it is, I believe. Or unless you don't care at all about it, then you know the project will most likely die. So
yeah, that's a great discussion. I think it's really important to prepare for working with open source code, with open source project to begin with, and this is, I think, all the panelists mentioned. So let's move to another question. So, okay, we decided that we're gonna go for an open source project, and this is our choice. So how do we structure the work, and how do we maintain an open source project? How do we go about the roles? Like, for example, like who makes the decisions, who to appoint as maintainers, who to take contributions from, and so on. So what are the suggestions? What are the right strategies that worked in your experience? Jason, maybe you can start.
Sure. So the quick answer is there's no one answer for this. It depends on the project. There's a lot of common examples of ways to do it. Things like benevolent dictator, things like a general meritocracy. There's lots of different governance models. And I was actually recently surprised by this, that there's actually a whole field of research into open source governance models and how the governance model influences the software engineering, how the software engineering influences the governance model, and like this socio-technico interference between the two. Like there's a whole thing of research on this. So there's no good answer. Here in a minute, I'll drop a link to some papers on this. But I was like at a few weeks ago, there was a workshop on open source software sustainability. And I'll tell you that people at Linux Foundation, Apache Foundation, in charge of big open source projects that are not just in academia, they don't know the answers to these questions either. So it's a really good question.
I think it also depends when you start your project, if you have like initial funding. And again, like what Sarita, probably it will be interesting to hear your feedback. Like when you start from a project or you have initial funding, there you probably need to, from the start, to understand approximately the structure of a project. If it's a 1 or 2 student project, then it's completely different. And again, there I wouldn't bother even about thinking about that. It should come naturally. You start progressing, people start being interested in your project, you get a bit maybe more interest funding. It can be self-governed. If it's a self-organized project, people get in and start participating. If you get funding from a company, then again you can make a structure, but it's there is no single answer to that.
I also really wonder to hear, from research open source project, the perspective of a research open source project, where I guess every student has, a spawn of their degree, like PhD student, master student, and so on. And projects usually outlive the particular individual contributors. So I wonder if anyone can share some, to do, what to do, what not to do.
So could you? I didn't quite get the question.
So compared to industry-initiated open source, where there are employees, students have very limited time when they start working on the project, when they finish working on the project. So how to structure the work so that maintainers just don't disappear, for example, or like contributions stop being maintained and things like that.
Yeah, this is an important problem in academia, right? This is a real problem. And I think I think the community needs to understand the importance of maintaining. Now, of course, if you're doing a project that is kind of short-lived, right? I mean, nobody cares about your work once you're done, and then nobody cares, right? But if you're doing some work that you really want people to use for a long period of time, then part of the funding structure needs to involve the funding for maintaining that piece of code, right? And yeah, and so of course the student's going to graduate, probably do new things. Probably they don't, they may get into an area where they don't care about this code anymore. Well, nothing can be done about the fact that the student feels that way. It's their right? Now, if the PI, the faculty member who's leading this, also feels that way, well, nothing can be done about that either, right? But now, if the faculty member the vision is such that, okay, the student's work is part of something larger or something they want to maintain, then I think the funding structures have to evolve to a point where such type of maintenance is possible, right? And this is changing. So NSF now, for example, has a fair amount of funding for infrastructure. Right now, it's not perfect, but at least there exists that funding, and so we are able to avail of that funding to hire programmers who can keep these things going. Now it's really hard, right? It's really hard that the student is gone and who's going to maintain this. But that's where we sort of close the loop here and go back to what Grigore and Jason was saying, is that if you're going to write code that you think is going to be open source someday, then that code will never be open source someday, right? But if your whole intention is to write code that people are going to use right from day one, then like a programmer in the group or someone like that sort of taking it up and just maintaining it and also ensuring that others are able to contribute becomes a thing, right? Then it's possible. So it's hard. We need a lot of change, but I hope we get that change, and we seem to be going in that direction, which is great. And I've suffered personally so many times, right? We take some code from some GitHub repo. There was this awesome paper somebody wrote on this great algorithm that we absolutely have to compare against, or we want to build on. And you use that code and nothing works. And there are nobody's answering questions anymore. Nobody's maintaining it. That's just terrible, right? So NSF or whoever funded that piece of work, basically, I mean, it got nowhere, right? And so it's the responsibility. I think the funding agencies need to understand, and they are, right? It's changing, that this is in the best interest of the community to support such things.
These are a number of great points.
Can I add something onto that, Dimitri?
Yeah.
So I completely agree about the funding, and that is getting better for sure. But I think that another piece of it, and I'm really glad you brought this up, Sarita. I think another piece is somehow giving credit to these kinds of things as well. So, and this is another thing that we need to work on in our community is, rather than, in my case, creating a new simulator and being able to get a paper out of it, you should be able to get similar kinds of credit by improving the existing work, or maybe even for doing things like maintenance. Now, clearly fixing a bug is not the same caliber as a paper, but adding a big new feature to some existing system should be. And our current system of writing papers to get credit, or even writing tool papers to get credit, I don't think it's working very well. And this is another thing that we need to be thinking about, how we're going to do that in the future. We want to incentivize people to do the things that will generate impact in the long term. And right now, people are not being incentivized to do the things that will generate impact.
Can I add also something to that? So first of all, I agree with both Sarita and Jason, very good points. And this maybe relates to what we started the discussion with. So for me, when I was a long time ago, PhD student, one of the things why we didn't start sharing code was the same issue that was scared at that time that someone will steal your code and write a paper without you and so on. Obviously, it happens and it may happen now. When I was a postdoc, I started releasing everything from the start before the project. I was still scared about that people could steal your work, would not give you a credit and so on. But then what happened is that when you release a code and it actually works, so you try to spend an effort doing that, I started having people like contacting me and started collaborating with me. So actually the world out there is nice. It's not we're scared, of course, because different reasons, but people are nice. They're getting back to you. And for me, the best thing I remember when I released everything in 2009 of our milepost GCC, and I remember people telling me, my God, now everyone will steal your work and so on. And I was scared. And the best thing was that I suddenly started getting feedback from lots of people whom I continued collaborating with over years. And I established strong collaboration. We got even more papers. We got even more impactful research. So that's why I think we're too scared of releasing code and then scared that it will be stolen, but it's not. You can actually have much more collaboration and papers afterwards, and this will be your credit. So
Totally
just
agree.
an extra point of the discussion.
Yeah, totally agree. Yeah. I think what Jason said about incentivizing for this type of impact is so important. And I don't think our community is doing a good, not even a half-ass good job on this, right? So we really need to change that. And I think it's really important to change that. I think funding agencies are doing a really good job, right? Really stressing the importance of artifacts, open things, and open data sets and all of that, right? But it's the program committee reviewers who's really people like us and the people who evaluate others, right? And so I've sort of made it a mission to really downplay the number of papers someone has and ask, okay, what is their impact, right? Well, it doesn't have to be open source software, but really be more impact focused than just number of papers focused.
Yeah, that sounds fantastic about like how to maintain an open source project, how to have our like organization, how to involve other developers, how to give them credit. That's fantastic. So now we are moving on to another stage of the open source project. That is, we already have a community. We are working on our daily maintenance of this open source project. Then it comes to a problem that happens all the time. That is how the communication will happen between the developers and such a large community. So our first question will be like how to communicate efficiently with the developers. Because, for example, open source developers, they have their own schedules. They may not respond promptly. And so discussion might take a really long time to finish. For example, I have my personal experience with Linux mailing list that sometimes the review can take like months to appear. So in such kind of like communication scheme, are there any skills that can make the communication more efficient that you push this discussion to an end and come to a conclusion, something like that? So how to communicate efficiently with the developers, that would be something very interesting to us.
I don't have a good answer for you. Everything kind of sucks for a different reason. Like, we use email, but not everybody uses email. In fact, we have a lot of contributors from, like say China, where email is less common. And so it's really difficult for us to communicate with them via email. We use Slack, but Slack has a problem of you have to pay per user or your messages go away in 90 days. So there's no history. We could use something like Discord, but then not that many people know about Discord these days. They're all bad for different kinds of reasons. I will say, as far as like generally how to communicate, what's something that I don't know if this is surprising to you or not, a lot of people in our field forget is to be nice all the time. Like, it's really important when you're communicating, say with developers of a tool, that you understand that they are taking time out of other things to help you, or vice versa. When someone asks a question about your tool, they're interested in using your tool. Like, it's not a stupid question. You shouldn't talk down to them. Like, they want to use your tool. They're interested in learning. So being nice and polite and, from a more technical point of view, having things like a code of conduct in your project is really important.
Yeah, I think the being nice part is super important. I think Elixir is not at a point yet where our community is so large that that we have to sort of deal with conflicts between what other people want. I mean, it's not been too much of an issue, but the issue that we have had to face is, as Jason was saying, some people. So we have a Discord. We encourage people to work with us on Discord, so everyone else can see what's going on and avail of that experience. But some people, especially in companies, if they're using Elixir, they want to keep it quiet, and so they will send emails, right? And they'll send emails to. They want a single sort of point of contact, and that's not always possible. Partly because, especially the student, especially if this stuff is sort of more cutting edge and it's a student responsible, they're not going to be able to respond in real time. So, I mean, these are sort of day-to-day issues that you have to face. And then, there are times when it's been 2 weeks and the email has not been answered by the student, and you just apologize, right? And you just hope that they understand, and so on and so forth. So yeah, so we are still in relatively early in terms of, like, we don't have tons and tons of users. We have lots of users, but not to the point where it's totally unmanageable or anything like that. And we encourage Discord as our main communication mechanism, because XR, right? Discord is like sort of the place where that community hangs out.
Kind of the same for us. It's first of all, it's very tricky to communicate with the community, and the same, we don't have the ideal scenario. We use Discord. We use a lot Notion to kind of structure the project and try to at least keep some structure for the project. So Notion seems to be pretty kind of useful and connecting for me. Notion plus GitHub plus Discord, it seems to be okay, but still the same communication with like people you forget, like there are GitHub issues, there is like something on Discord, and it's becomes a mess. Maybe just one suggestion. So if your project grows and you have a big community, you should probably start looking at foundations like Apache Foundation, Linux Foundation, because good or bad, they start providing you like help with that and provide you some structure, because there are so many projects which graduated from those foundation. They already understand the problem and they help you with that. So that's I found. So I joined ML Commons, so which is another organization. It's not yet that mature, but they also help you with that. So maybe that can be something.
Yeah, we have every other week. So it's been on hold for a couple of months, but we've been having community meetings every other week, and so that's helped a lot in terms of getting input from people as to what are the issues and so on. So that's one thing we've done, and we want to restart that again. Yeah, I don't have any silver bullet here.
Actually, maybe getting back to that. Oh, sorry, Jason, please.
Or you go ahead.
Maybe very quick. So that's another thing for like students who want to open source their projects and work with the community, that to some extent we also started doing regular conf calls weekly, bi-weekly. It takes lots of energy, but once again, you have to commit to that. And this helps because someone forgot something, then people can actually once in like 2 weeks see you in person and at least tell you that you forgot about something or something urgent. But it's lots of energy and you need once again to commit to that. So.
Yeah, I think I was gonna say, going back to the funding stuff, while the funding agencies have been getting much better, they see how important it is to maintain these kinds of things and fund these kinds of things. They're still very focused on the technical side, and there's not as much funding for something like a community manager. And when you get to, say, the size of Gem 5, we really need something like that, but there's just no way to get the resource to be able to hire somebody to do that kind of work. So Gem 5 is unique because it was huge And then we tried to make it more of a capital O, capital S open source project. So we didn't think about these things as we were growing. And now all of a sudden we're huge and we don't have a lot of things in place to do these kinds of things.
Could you get some sponsorship from companies to fund directly instead of NSF, like fund community management directly?
So companies are even worse than NSF for not wanting to fund the underlying infrastructure. They want some new feature, and that's all they care about.
Mm.
At least that's been my
Okay.
experience.
Okay. Yeah. Can be true as well, yeah.
Yeah, very interesting story. So with all being said, so there's one more question. It's more like asking for advice. So what would be your advice to the students who are about to start their open source project, and how they should expect themselves for such kind of communications, what they can prepare themselves to like be more efficiently communicating with other developers? So any kind of advice regarding communication to someone who has no experience yet, but they are planning to do so. So any kind of like advice, anything will be useful, will be greatly helpful. I think being nice is a very important thing. So I myself, when I first tried to contribute to Linux, it's a very small piece of testing code, but my Google internship mentor, he really taught me like try to be nice. We have these like ways to show our nice to others, and it really helped a lot. Like people are really willing to help me, and they really help me solve a lot of problems. I think that's a very important part. And other than that, is there any other advice that people can prepare themselves for the communications?
So
Yeah, go ahead, Jason.
I think my advice would be, and Grigori has said this a couple of times now, think about the kind of impact that you want to have. Do you want your impact to be more people read your paper? Well, you're going to do a different kind of way to open source and support that in a different kind of way. Then maybe your impact is something like Elixir, where you want to build this giant community where people will come in and start using this and push this entire field of research forward. Then you're going to do something very different in that case. And so being conscious of what the impact is that you want to have is the advice that I would give.
Yeah, and I'll just pick up on that. And again, Grigori alluded to this as well. A lot of our quote unquote impact has come, or the benefit for us, I should say, honestly, has been the large number of collaborations that this has spawned, right? And so there are companies using, so some companies are using it internally and we don't even know. Some companies use it and then once in a while they send us email, right? And then we answer them. And then some are actually working with us, right? And so now, so there, what is the communication? The communication is once a week research meetings and, a bazillion emails between each other and writing papers together and so on, right? So that's one form of building the community, because when a company is using your work and you're working with them so closely, that's a whole huge, a whole huge different thing, and the communication there is entirely different. And then there are sometimes, random students just looking at your work and using it for, just like hobby kind of projects, right? And that's another kind of communication. Then there are people who are actually working on a paper and want to use your work, and they're asking you questions at the sort of the day before the conference deadline, where it's the same conference deadline for you as well. And that's really tough to be able to deal with that. But I think people understand, and as long as you're nice and you know what you're trying to do, they understand. But anyway, the larger point I wanted to make was one, don't underestimate the value of collaborations that you get from projects like this. I think it's not just for you, but it helps move the field forward. And as Jason said, think really, really hard about what type of impact you're looking for. So one of the impacts of Elixir is that because of this, we now are launching a big center at Illinois that's bringing together the entire campus community. And it's not because of Elixir, it's just because of the sort of the confidence and the, it was a launch pad for us, right? And it's an impact that I would have never dreamed of, but it would have never happened unless we had this really strong infrastructure already in place. So yeah, it comes in different forms and the communications are different. By the way, I give like a bazillion talks, I'm giving talks on Elixir all the time. That's another form of communication. Yeah.
That's a really interesting discussion. Communication is very important, clearly. I also wonder how to attract, if people can comment on how to attract contributions and how to work with external contributors, how to structure the procedure of accepting contributions and moderating them and so on. So it'd be great if you can share your experience.
So again, I think everyone, like every project is different. So if you start growing and you start having contributions, it's already a good problem to have. So many projects don't get even to that stage. So, and then maybe for our sides, like with collective knowledge projects, which work with ML Commons, maybe we don't suffer so much. We have moderate amount of contributions and we don't have such a huge problem of like moderating that and so on. So yeah, I guess it depends on the project. I can't say more. I think here it's again, I would probably hear like from Jason or Sarita what's happening with your projects, how it works in your case.
Yeah, I mean, we haven't reached a point where the number of contributions is so much that it's like, driving us crazy. It's just, it's more, so we have reviewers, right, that need to go through everything and we're always behind. I mean, that's like, because yeah, that's the nature of things. So that's our biggest problem, but we haven't had issues related to, any other sorts of issues.
And once again, just like getting more contributors, eventually it depends on the project. The project continue growing, you have more contributors naturally. I wouldn't, how to say it? Well, it relates to communication as well. So we continue talking to people, we get more collaborators look at this in your code, they start using it, then they continue contributing. I don't think we do anything specific to attract like contributors. We have some projects, maybe an interesting thing. Again, I don't know what in case of Jason and Sarita. So we plan to participate in like Google Summer of Code. And I know that this can be like such kind of programs are very interesting because there you basically get students who are paid and who are having like some interesting summer projects to work on. So that's how you probably would specifically get more contributors. That's what I would probably suggest.
As far as like technical things to do, I think there are a few things. Thinking about ways to lower the barrier to entry to contributing is important. That's something that I think Gem5 fails at terribly. I think the barrier to entry is way too high for Gem5, and I think there's a lot of people that want to contribute that don't because of that. Things like having a contributing.md document, having a code of conduct, those kinds of things are important to bring people in. And then documentation, documenting how to contribute, documenting how the code works so that you're not wasting time in code review telling people things that you could have written down somewhere else. I think those kinds of things are all important.
So why did you say the barrier is high, Jason?
So for Gem5, for instance, you have to learn how to use Gerrit. Not that many people know what Gerrit is. You have to create a Google account in order to do that. You push something and then the CI test says it fails, but it doesn't actually tell you where it fails.
Yeah.
So we have all these little things that could be solved. They're all very easy things to solve. But trying to find the resources to solve those things is difficult.
Yeah. I think, definitely we are, sorry, Grigori, were you going to say something?
No, please go ahead, sorry.
No, I think, getting our CI pipeline and our testing framework up to date and so on has been, it's an ongoing thing, and we try to do our best is all I can say.
We're struggling with that too, absolutely. And one thing, so for me, I'm building one of those automation frameworks for many years, and for me, each time with a new design, actually the whole redesign was every like 3-4 years was to reduce the barrier of entry, reduce it, like minimize dependencies and doing it. And I'm not saying we did it like perfectly. I think so far we're much better. We have like minimum dependencies. But then what we're also lacking, and okay, documentation, of course, but what we'll try to do this year, we had lots of feedback, people asking us to do small tutorials and demos and put them on YouTube, but like really small ones. Personally, I didn't do that. I know some other projects are doing that, and I think we'll try. That can be useful. It's, again, many people look at you like how you would do it, something simple, and how you would contribute. So that's what I would suggest people to do.
Yeah, I mean, right now we are in the midst of overhauling our build system, just like you were saying, just to make it much easier. And that's not so much necessarily for contributors, it's for users as well. So yeah, definitely all that infrastructure needs to be top notch, not just for people to contribute, but for people to use it as frictionlessly as possible. And then tutorials and so on. I totally agree, Grigore. We've tried to do that. I think we need an upgrade on them, but we certainly have something reasonable out there.
And just to say again, like it's a good idea to think about these things early, because the experience of trying to add continuous integration to Gem 5 after it had 500,000 lines of code is really, really hard. So thinking about it early. What we're saying is follow good software engineering practices.
Yeah.
Actually, I was just thinking about like what you're saying is we need to have some basic template for open source software where you have everything in place, like GitHub project with a CI with basic tests, and that could be an outcome of here, like getting it to students, something simple. We have like what we do. We usually use other projects, but here just like having a template like this could be useful, because then all the students could start using it, and at least basic automations will be in place, so that then they can extend it and scale it later. That's why I'm actually writing it down, because I think, oh, that could be nice to have.
A checklist.
Yeah, and Jason was saying there are a lot of people actually who are working on making high quality research software a more common thing. And I don't know if they're doing what you're talking about. Some of them are on our campus. I'm happy to pass on what you just said, Grigore.
But this actually relates. So I continue working on artifact evaluation, and this year we're helping with micro, and there once again, each time I'm trying like to get some automation, or we're trying to do it slowly, because again, we don't want to force students to open source everything or like to have the perfect technology, because it's, again, depends on you want it or not. But these templates, I'm thinking for a while, and actually starting from conference, giving at artifact evaluation some of the templates that can be maybe a starting point. So, and yeah, if we can connect to discuss like offline, I think it can be really interesting. So I may try it actually at some of the artifact evaluations in the future.
Yeah, very interesting discussion. And speaking of like these testing and CI things, that brings me another thing that is really related to the student research, that is the research artifact reproducibility. So these days, many system conferences and other conferences, they are putting up this artifact evaluation procedure for the students to submit their code and make sure the code can generate at least similar or almost identical results as in the paper. So it's a very important part in system research these days, and also maybe computer science research these days in general. So we have a couple of questions that we are really interested in. So first would be like how to improve the open source projects reproducibility for like other system research projects. So for example, you have a piece of code, some others probably want to use that code and they want to do a reproducible procedure. So how to improve your like infrastructure for others to use your system research project?
Grigore, do you want to
I'm a bit scared. I'm a bit scared of getting into this topic because there is still lots of frustration going on about that. But yeah, maybe it's actually very briefly something what I think Jason mentioned at the very beginning. So I still see sometimes at conferences that people just throw out some code and they say, oh, now it's reproducible, or they put something better like Jupyter Notebook or container, which improves things, but it still doesn't make things easy to reproduce. Why? Because someone still needs to understand what is your code. And I mean, replicating it probably with a Docker, you can get some result, but it's still kind of black box. What do you do with that? So we need to have guidelines where we have at least some kind of an API to your project interface. That's why kind of like what I wish to have one day is that every project have a similar API, like kind of human readable API. What do you do with the project? It relates to Jupyter Notebooks, but then we forget again, we have to deal with lots of dependencies. Hardware is different, software is changing all the time, and still people just forget about it. You write your script, you share it, and you say like run it, reproduce something. What do you expect the results, and so on. There are lots of things. Just to conclude what I'm saying, when I started artifact evaluation with many colleagues, by the way, it wasn't only me, there were it was a huge collaborative effort, and I was one of many people who work on this topic. For me, I was pushing for a long time a unification of what we call artifact evaluation appendix. So I kind of proposed it years ago. And there, the idea was that you start describing at least what is your project about, what are your dependencies, what are your inputs, what is your expected output, and at least it becomes not a black box, 2 pages appendix, which was picked up by CM and by many conferences. But our next step is kind of probably my wish to have automation where kind of workflows, where we start with your project and I can adapt it to my system. So I can run it with different dependencies, with different software, hardware. I can run your project and get results. They may be slightly different, but at least I can run it on my system with completely different dependencies. I don't know if it answers the question or not, but it's just there is still a long way to go between what we have now when we have artifact evaluation and what I wish to have in terms of reproducibility.
I think one thing that's really difficult, and this has been my experience on both sides of the artifact evaluation thing, both submitting papers and also being the chair of artifact evaluation committees, is that it takes a lot of work to do a good job of being able to reproduce your thing. And so I think that the badges on papers are great. I really, really like that, but that's not really giving people credit for all that work that they're doing. So having things like, and again, this comes back to thinking on a community-wide, how do we incentivize people to do this? So having awards like Best Artifact or things like that, I think could really go towards incentivizing people to put effort into making it easier to reproduce their work. And
so I think,
here, for the students here, I would say, think about the impact you want to have, because having an artifact that's easy to reproduce will increase your impact. It'll mean more people citing your paper. It'll be collaborations, as Sarita talked about. Your impact will be improved if you have good reproducibility.
Yeah, but we should also go further than that, right? So I feel that if I'm writing a paper about an idea that is similar to someone else's idea, right, then reviewers expect me to compare my idea to that person's idea, right? Well, if their code is not available and not usable, I just think we should get to a point where we are not expected to compare ourselves to them. I mean, their idea is just not, I don't know, they wrote a bunch of stuff in their paper. Half the time the details are not there, you don't really know exactly what they did. So that would really incentivize, right? So if you say that, hey, unless you have this idea, so others have to be able to reproduce it and be able to compare new things with it for them, for these other people to be sort of obliged, right, to reference your work. Well, that would change everything.
I love that.
The panel, we've all been way too nice. So let me disagree here.
Yeah.
This has not been what we've been agreeing too much. I like the idea, but I don't think that the artifact badges are going to help us get there. Because
No,
in
I don't
my
think so. I never said that.
experience-
Yeah.
Well, so like my experience of these current things is like, you know, papers get badges saying they're reproducible, but it's just a black box. It could be on the inside, just a function that returns the number that's in the paper.
Yeah.
And if that's what our badges are that say reproducible, then what you're saying is going to cause a huge issue, right?
Yeah, I'm not saying that our current badges are doing what I'm asking to be done. I'm saying I'm asking for something completely different, and I think that will really change things. And I think the standard sort of pushback on that, which I used to use at one point long ago, is that, oh, it's going to slow science down because now, people who are who are coming up with these ideas, now you're sort of constraining them to build products and so on. And maybe that's not an academic's job, et cetera, et cetera. But after having suffered for, the same students are spending so much time trying to reproduce other people's work, right? So if you look at the whole community-wide efficiency, it's worse. It's only going to get better if we make it easier for people to, and if people don't want to publish artifacts out there, I mean, that's fine. They can put their ideas out, but then don't expect me to compare my work to yours if you don't have the code for me to see, hey, you talked about these cues. I mean, like, what was the length really? Or, how long did it actually take? Blah, 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 right? Whatever the detail is. If I can't find it from the paper and the code is not there, then I shouldn't be expected to evaluate myself against you.
So agreed, but I think it's more than just the code being there. It's the code has to be usable.
Yeah, exactly. Yeah, absolutely.
Actually do what it says that it does.
Absolutely. And if it doesn't do what it says, then a reasonable contribution should be this code was published and it doesn't do what it says. Right? And then you do it the right way. Make sure you bring the authors on board and so on and so forth, right? So there's a whole thing to be said for that. But I think the expectation has to be that that the work, if you want others to compare themselves with your work, then the onus has to be on you to make your work be at a point where people can compare against it.
So just maybe my quick comment. I actually agree with both of you on the way that, first of all, the badges at the moment clearly are not enough to say, let's say that the code is reusable. Actually, I don't know if you know, but there is a badge reusable. I actually suggested to have it about 5-6 years ago, but my idea was actually that part, that in comparison with reproducible code, which can be extremely difficult to reproduce, the idea is like of having reusable was that you as an external person can run it along with your system without lots of suffering and get a result and compare result. But unfortunately, those texts which I had originally was mentioning that it was removed because it was too complex, I think, and it left like reusable. It's like just a better standard of kind of reusability. It was, no one knows what it means anymore. But maybe we can get back to this kind of discussion with ACM and tell them this, what we're discussing today, that I totally agree with you, that we need to have this better kind of reusability and comparison. And just to say, when I was doing a my PhD, I was comparing matrix multiply performance, and there was like some static methods to calculate tiling sizes and so on. And I was reproducing papers, spent like half a year reproducing papers. I couldn't do that. I was talking to an author, and thankfully the author discussed with me, and we found that there was a flaw in the paper. Again, we'll not say who and how, but it was depressing because as a young PhD student, you're actually scared of talking to an author who published a paper because you may think that, oh, I'm wrong, I will like ruin my career and so on, because if I'm wrong. And that's having a code, reusable, reproducible code helps you with that too.
Yeah, that's totally true. So this also brings us to another question that is more like, as a student, we are facing artifact reviewers. So what can we do as a community to improve the guidelines for these reviewers, not students? Like what guidelines we can provide for artifact reviewers so that they can consistently evaluate artifacts reproducibility? Because as a conference, we might have like tens of or even hundreds of like reviewers. reviewing artifacts, they may not have a very consistent evaluation procedure. So what can we do to improve that part to help the students who are submitting artifacts to get a consistent, reproducible reviews, something like that?
I don't think
It's a
anyone's
hard
gonna have an
question.
answer for that question. Like, you can ask the same
Yeah.
question about paper reviews.
Uh-huh.
Also not have a good answer to it. It's difficult.
Yeah, I mean, I personally been through a few like artifact evaluations, and I see they have like quite different evaluation standard. Like some conference will say we can reproduce like say how many percentage of the results that's reproducible. The other conference will say we have to reproduce 100%, probably not that much, but a different like percentage, something like that. So is there kind of like anything that we can do to make it more consistent, or maybe not? It's really hard.
Well, so I mean, every conference is different. Every program chair is going to be a little bit different. But one thing we could do is lobby to change HotCrap so that we have some of these, like HotCrap now already has automatic things for regular paper reviews. It doesn't have that or it didn't have it a few months ago for artifact evaluation. So that's one thing we could do, is put some automatic things in HotCrap to try to make it a little bit more consistent. I don't know if that's something you've looked into, Grigori.
So so I started doing artifact evaluation in 2014, 15. So for me, one of the reasons why I continue being involved in that is each time we have actually feedback, asking for feedback from both reviewers and the authors about the process. And each time we're trying to kind of come up with a relatively universal way. And as well, by the way, we continue having our own setup for HotCrap. So you can, by the way, you can use, or anyone can use this kind of standardized. Now, the problem is exactly what you said is it depends on the conference. I'm working a lot with system conferences. There it's actually very tricky, because if you want to even like reproduce, let's say, full simulation, I mean, it's often pretty impossible. So what we ask usually is that we're asking to have key results, to reproduce key results. Again, it's also like not necessarily clear what it means. Just maybe what to say, what we're trying to do is, my personal way of dealing with artifact evaluation was always to connect reviewers and authors from the start. They're having a discussion. We provide them a channel, and often on HotCrap, by the way, that's what we're doing, a setup, where they from the start, they're not waiting for 1 month trying to reproduce results and then tell authors, oh guys, you know, nothing is working. From the start, they start working together, figuring out, and we're basically moderating that. So we see that, and usually have 2-3 reviewers, so someone start becoming very picky. Sometimes we have like very picky reviews, but it's also nice. And then you moderate, and then eventually you try to figure out what is the outcome. I don't think we didn't find, unfortunately or fortunately, a better way to deal with that so far, but we have kind of unified guidelines.
I think I'd said before, I have to drop out top of the hour. So very nice hanging out with you all, and thanks for the great discussion and organization.
Thank you for joining.
Thank you.
Thank you.
And actually, we should start wrapping up. We have a couple of questions from Zoom. So the first question is, so the person is concerned if they open source too early and the quality of the artifact is too researchy. Do you think it may hurt the visibility, the impact that the artifact would have? For example, if people would get distracted by and discouraged by the quality, because many of the panelists mentioned that it's actually important to do it earlier. So what would be your recommendation for this question?
So I have 2 different answers. One is you shouldn't worry about being embarrassed about not having high code quality. All of us write code at low quality. We're doing it fast, or we also just all make mistakes. Like the most expert software engineers make mistakes. So you shouldn't be embarrassed about putting your code out there. Now, if your code is so bad that it can't be used for what it's intended to be used, that you should be improving it so that you can use it, improve it for yourself, right? Not for the community. So like, don't be embarrassed by it, but also produce tools that are useful, I guess would be my answer.
I like that answer. I think it's like your tool needs to bring value to people. If it doesn't bring value, then no one cares. If it's well written or if it's badly written, if no one uses it, it doesn't matter. So, and the rest, again, as I said from the start, that I see open source projects as a startup. So you need to do things, mistakes, iterate and improve things. And what Jason, I like what you said is, I think it was the same for me, that to some extent, you need to be a user of your own tools. And because in such case, you kind of, you use them every day, you try to improve them for yourself, and then you love it like it's your own thing. And then hopefully community will also start using it. So, but yeah, I agree with you, Jason.
And this is a great point. And there is another question, which is more, I guess, about communication that we already discussed quite a lot. So the person asks, how does an open source project should coordinate across different contributors that may have different styles, practices, degrees of coding expertise, probably also, in academia, in industry. For a project big enough, there is a total mix of different people trying to contribute. So what would be your recommendations?
There's lots of different levels of contributions, right? Not every contribution is improving the core of Gem 5, or like the out of order core in Gem 5. Not everyone has to understand how that works to contribute to the community. Asking and answering questions on the user's mailing list is a form of contribution. And so encouraging people to be part of the community is kind of, what I would say. And then I guess the other bit, as far as like styles and stuff, is lowering the barrier to entry for contributions, such as having an automatic code style thing, where there's no argument on, no one ever argues about the code style because it's automatically changed. So Python Black is a great example of this. You can't argue with it. That's what Black said to do. So those kinds of things also help lower the barrier to entry to contributions.
For me personally, I think it's again depends on the stage of your project. At the beginning, I wouldn't bother about arguing with contributors if they had a very different style and so on. You need to have first contributors, and you are happy to have them, and you need to support them even if you don't necessarily agree with them. If the code grows, project grows, it becomes more popular and so on, then you would clearly have to start bringing like styles, practices, and so on. And once again, that's where some mature projects move even like to Apache Foundation or other stuff, because there you would have all this structure in place. So that's why it depends on the project on the project stage. But at the beginning, I wouldn't bother, to be honest.
That's cool. So that's all our questions from the audience. So, all right, I think this will be the end of this panel discussion. And what a great time to discuss all these topics and have all our questions answered. We really thank our panelists for taking the time to come and share their experience on open sourcing. And this will greatly benefit for the students in the computer science research area. Yeah, also we students at Systems are organizing a few follow-up online events in other topics. So if you are interested, please follow us on Twitter and LinkedIn and YouTube, and also check our website. With that said, we would like to thank our panelists again, and this will be the end of the event. Thank you so much.
And thank you for organization.
Thank
you very much.
Thank you, Jason and Gregory. Thank you.
Thank you.
Bye.
Bye.
Stop recording.
We can stop the recording. We can stop the live.